Hello and welcome to another Portworx demo. My name is Bhavin Shah and I'm a technical marketing manager with the Cloud Native Business Unit at Pure Storage. In this demo, we are going to put on our developer hats and look at how easy it is to deploy a Postgres instance on my Amazon EKS cluster using Portworx Data Services or PDS and start using it as part of my application. So to get started, I have logged into the PDS portal as my user account with my user credentials. And I can already see all the different data services that have already been deployed. So I have a data service that's deployed by a teammate of mine on a different EKS cluster. And you can also see the list of data services that are available for you to deploy on your own Amazon EKS clusters. So as we said in the start of the demo, we will deploy a Postgres instance. So let's select that. We'll start by giving it a name. So the app is a Kubernetes counter application. So we'll give it a name. So Kubernetes counter DB. We'll select a target cluster. Again, I'm deploying this on Amazon EKS, but you can also have AKS clusters, Red Hat OpenShift clusters, vanilla Kubernetes clusters, and attach them to the PDS SaaS-based control plane and use that for deployment. We'll select the EKS cluster and PDS will go ahead and fetch all the different namespaces that are available to me to deploy my database instance. I will select the demo namespace, which we have specifically created for this demo. And then we'll ask PDS to automatically provision external load balancer interfaces. This will help us with service discovery and give us a connection string that we can immediately start using as part of our application. Next, let's select an application configuration. Again, these are runtime parameters, key value pairs that can be provided to our Postgres instance during deployment. For this demo, we'll keep it to default. We'll obviously come back in a different demo and cover what these application configuration templates and resource templates mean and how do you configure them as a platform admin. But as a developer, I don't need to worry about all of this. If I hit on show details, it tells me, okay, the database that will be deployed by default will have a name called PDS, and that's it. Next, let's select a size. So again, since this is a demo, we'll go ahead with small, but you have different t-shirt sizes available to you, which have resource limits and quotas for CPU, for memory, and for the amount of storage that gets provisioned for each pod. So here we are selecting one vCPU as the minimum and 2 vCPUs as the maximum. Same with memory, 2 gigs memory as the minimum, 4 gigs as the maximum, and 100 gigs of persistent storage for each pod. Next, we'll select the number of nodes that we want for our Postgres instance. By default, if you want a highly available Postgres instance, you should select something that's more than one. But again, this will depend on your application or your deployment. Next, we have storage options. So PDS does give you a few default storage options, but your platform admins can go ahead and configure additional storage options as needed and will be represented in this drop-down menu to all of the developers. So we'll select the default, which will deploy persistent volume using XFS as the file system and a replication factor of 2. Optionally, we can select backup jobs as well. So at deployment, if I want this Postgres database to be protected every hour, every day, every week, I can configure those backup policies and select a target. Since this is a 101 level demo, we'll keep that as no scheduled backups. Again, you can change this after you have deployed your Postgres instance as well. Next, let's go ahead and hit deploy. And this initiates the deployment of this Postgres instance on my Amazon EKS cluster in the demo namespace. So you can monitor the deployment of the Postgres instance from the PDS user interface, or let's go ahead and navigate to our EKS instance and let's do a kubectl get nodes. And here you can see it's a simple 3-node EKS cluster that's available for our demo. And if we look at all the resources that are getting deployed in the demo namespace, you will see that we have pods coming up. Postgres instance is getting deployed as a stateful set. So you will see that the 3 replicas or 3 number of pods that we configured are the number of replicas that are configured for the stateful set. It deploys all the different load balancer instances for service discovery. We have pods that are in pending state. So let's do a watch command on the pods and make sure that they come online so that we can use it in our application. So since this is a stateful set instance, the first one will come online once it's fully operational. That's when stateful set will spin up a second one and then the third one. So as you can see, our first and second are almost up and running. We'll wait for the third one to come online and we can start using this Postgres instance. Let's go back to the PDS UI and look at the progress from there, what it looks like. So as you can see, 2 of the pods are already in the green state that are up and running. The third pod is coming up, so it's still in the deploying stage. Again, if you don't have access to your EKS cluster, you can monitor all your different database instances from the PDS user interface itself. So let's refresh this and see how the deployment is going. Using the UI, you can do a couple of additional things. You can look at the metrics. Again, this is something that we look at when we deploy our front-end application. And you can look at connection strings. So now all 3 of our pods are running. Our PDS instance or a Postgres instance on our PDS in the PDS UI is showing as running. We can go ahead and look at additional details to get the connection string. So as you can see here, we have a connection string that we can start using in our application. We have a username and we have a password. And by default, the PostgreSQL pod is used as 5432. So let's go ahead and use this as part of our application. So let's go back to the CLI session. Let's clear this out. And we have a simple YAML file for application. Let's go ahead and update the values for our Postgres host variable or environment variable. So let's go ahead and remove the previous one that I had for testing and paste the new one. The username still is the same, but the password will change. So let's go ahead and delete the previous one, then go back to the PDS UI, copy the new password, come back and paste it here. Now we have a YAML file that can be applied in the demo namespace using the kubectl apply -f, the name of the YAML file, and -n demo. As you can see, this has been deployed. So we can go ahead and do a kubectl get all in the demo namespace. And you can see we have a deployment object for our front end ready to go. Like 3 of 3 pods are up and running. And we have a load balancer endpoint for the front end UI as well. So let's go ahead and copy this and paste it in a Chrome tab. This obviously takes a couple of minutes to come online because as part of EKS clusters, whenever you configure service type as load balancer, it goes ahead and creates an ELB instance for you. It maps it back to your EKS worker nodes and makes those connections active. So once everything is up and running, you will see a UI for our Postgres instance being available for you to generate some data. This is a simple application where you can use the user interface. So wherever you click, we generate a Kubernetes logo and store the coordinates, the XY coordinates in the backend Postgres instance. So this is how we are using the Postgres instance that we just deployed as part of a cloud native application. So let's go ahead and refresh this again and wait for it to come online. Now we have our application up and running. Let's click do some clicks and generate some data. As you can see, as I'm clicking around in the screen, the number of database records are getting updated and those entries are stored in our backend Postgres instance. So if we go back to our PDS UI, we can go ahead and hit the metrics tab. And here you can monitor your Postgres performance. So it will show you things like the read and write throughput, the latency, and from an application perspective, it will show you your transactions per second, your tuples in, tuples out, session server count, and block IO. So all of those parameters, both from the storage perspective and from an application perspective, get displayed in the PDS user interface. Let's go back to the dashboard. Here we can go ahead, like as part of day 2 operations, which we'll cover in a future demo, you can edit things like the application configuration template. You can scale up your individual Postgres pods. You can scale out and add new pods to the Postgres database, and you can select new backup policies. But again, all of that will be covered in a later episode. So in this demo, we basically showed how easy it is to deploy a Postgres instance without having to learn how different Kubernetes operators work, selecting the best one, using it to deploy Postgres on an EKS cluster, and handling all the day 0 and day 2 operations manually. PDS offloads all of that for you and provides you a simple user interface that you can use to deploy databases on any Kubernetes cluster. That's it for this demo. Thank Thank you for watching.